Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2014 for 2 marks in set 3. Basically this question is based on conduction topic. Again in conduction, the question is based on the composite slab, heat transfer through the composite slab. So let us understand the question. The question is, a heat transfer through a composite wall is shown in figure. Here the composite wall is given and in x direction there is a heat flow. Both the sections of wall have equal thickness L. Here you can see the first wall, let us say this is the first wall, this is the second wall, right? And for both wall thickness is L given. The conductivity of one section is K and that of the other is 2K. Now for first slab thermal conductivity K1 is K, right? Let us say this is a K1 which is equal to K, and thermal conductivity of second slab K2 is equal to 2K is given, right? Then the left face of the wall is at 600 Kelvin. Now the left face is this, right? Therefore let us say the temperature of left face is T1, right? Therefore T1 will be equal to 600 Kelvin. Then and the right face is at 300 Kelvin. This right face, let us say this right face will be at temperature T3, right? And T3 will be 300 Kelvin. And let us say the interface temperature is T2. Let us say this interface temperature is, I am assuming T2, right? Then the interface temperature Ti, here they have mentioned Ti. So let us assume interface temperature as Ti, right? Let us say this interface temperature I am assuming Ti, right? The interface temperature Ti in Kelvin of the composite wall is, right? In Kelvin we have to find this interface temperature. If I put T1 and T3 in Kelvin, then the Ti also will get in Kelvin, right? Now my dear students, through this slab the heat is flowing towards right, right? And my dear students, for steady state condition the heat transfer will be always same at each and every location. Now let us say through first slab there will be a conduction, as well as through second slab there will be a conduction. Therefore the mode of heat transfer is conduction only here, right? Therefore the first slab will offer resistance R1 and second slab will offer resistance R2. And my dear students, the resistance through the slab, right, or wall is nothing but we can say EL divided by Ka. This formula we have derived, right, where EL is the thickness of that particular slab, K is the thermal conductivity of that particular slab, and A is the area perpendicular to the direction of heat flow, right? Now for both slab area will be same, right? So my dear students, this will be resistance through both slab, and if I draw the equivalent circuit, whenever temperature is T1 to Ti, it is intermediate temperature, between temperature T1 to Ti there will be a resistance R1, right? There will be a resistance R1. This R1 will be equal to L divided by K1A, right? And between temperature Ti and T3 there will be a resistance R2. Therefore Ti to T3 there will be a resistance R2, and R2 will be equal to L divided by K2A, right? And my dear students, through this slab the heat is flowing. This should be the direction of heat flow Q, right? And this Q we can calculate. We have derived this formula. Q is equal to change in temperature delta T divided by resistance. Now if I consider temperature change between T1 to Ti, then I have to write R1, because between T1 to Ti there is resistance 1 only. If I write Ti to T3, then resistance will be R2, and if I write T1 to T3, then resistance is R1 plus R2, right? So my dear students, by equating these equations we can get interface temperature, right? Now let us equate first two equations. Here if I equate these first two equations, that is I am equating here T1 minus Ti divided by R1 is equal to Ti minus T3 divided by R2. Then I will get Ti from these equations. Let us put the values. Therefore T1 minus Ti divided by R1 is nothing but L divided by K1A is equal to Ti minus T3 divided by R2 is L divided by K2A. Now as length of both slab is same or thickness is same, length or thickness will get cancelled, area will also get cancelled because area is also same. Therefore from this we can get an expression that K1 into T1 minus Ti is equal to K2 into Ti minus T3. This should be our final equation. So let us solve this equation. Now my dear students, all the values they have provided already in the question. So let us put these values, right? If I put these values, now my dear students, the equation becomes K1 is K, T1 is 600 minus Ti is unknown is equal to K2 is 2K, K2 is 2K into Ti is unknown minus T3 is 300, right? So let us solve. Here thermal conductivity will also get cancelled. Therefore 600 minus Ti will be equal to 2 Ti minus 600, right? So my dear students, if I consider this 600, it will become 600 plus 600 on left side, right, is equal to, it will become 2 Ti plus Ti on the right side, right? Therefore we can say that 1200 is equal to 3 Ti. Now from this let us find this Ti. Therefore Ti will be equal to 1200 divided by 3, which is nothing but 400 Kelvin. Therefore my dear students, for this question your answer is 400 Kelvin. So here they are asking in Kelvin only, so here you have to type 400. Thank you dear students. In next lecture we will see one more numerical on this topic which was asked in previous year GATE examination.